Hello and welcome to this first ever lesson in senior secondary physics. I believe this lesson is going to be a motivation to you as you start your journey towards excellence in MSc physics. My name is Kanama. So in case you might have problems identifying your teacher, so I have to introduce myself first. I'm Chikondi Kanama. So my name often appears like this on digital platforms. And should there be any need for feedback, please reach me through the contact provided at the bottom left corner. I mean here. Okay. Otherwise, we are good to go. The first lesson we are going to cover in physics is units and measurement. So this is an important lesson because it is the lesson upon which most other lessons are built. You cannot express any other quantity which you are going to learn in physics without learning something about the quantities themselves. So that is why it is intuitive that you learn this thing first. So let's start our simple lesson. I believe it will be a very short one and easy to follow in units and measurement. So before we talk about the unit and the measurement itself, we have to know that units and measurement have something to do with a quantity. So it will be very important that we understand a quantity. So this whole lesson is dedicated to understanding quantities. Although the unit is units and measurement, but this part has the combination of all objectives relating to the concept of a quantity. So we define a quantity as a measurable property or amount of something. In other words, something that you can measure is a quantity. Let's for example talk about spirituality. Uzimu tingawuye bwanji? Tingane kuti andi uzimu 12, uzimu 3. That is something that cannot be measured. But there are some things that we really measure in our everyday life. Those things are physical quantities. Uzimu, let's say manta. I don't know if people can do that, but in physics that's not our concern. In physics we are concerned with things that can be physically measured, and those things are called physical quantities. So quantities include things like mass, weight, volume, and light intensity, because these things can be measured, as you know. Quantities come in two main types, namely base quantities and derived quantities. Base quantities are also called fundamental quantities. Fundamental quantities are those quantities that cannot be defined in terms of other quantities. You can't define them in terms of any other quantity. For example, within a quantity called length, inside length there is only length, nothing else. You cannot combine two other things to make length. It's not possible. Time, mass are other examples of base quantities. Derived quantities are those quantities that are combinations of two or more base quantities. For instance, density is a quotient of mass and volume, so it is a combination of two quantities. Momentum is a product of mass and velocity of an object, so it is a combination of two quantities. Our main business is to start looking at the 7 fundamental quantities, and then later we'll look at how other quantities combine together to make up these 7 fundamental quantities. We are going to start with the most important 3 quantities, which are sufficient enough to define a measurement system. Kuti munthu unene wapanga measurement system yako yokhazikika pakwena kukhala njira zowezera ma quantity atatu amene ndifuna fotokoza apapawa. They are the first 3 of the 7 fundamental quantities. We start with a quantity called length. A measurement system must be able to measure the length of something. Length is written like that. So length is a fundamental quantity. And then we have mass. Every measurement system must be able to measure mass, oyambira, and every fundamental system must be able to measure time. Even from time immemorial, when people had not invented sophisticated machines, but people were able to express utali wa chintu, kulemera kwa chintu, komanso nthawi imene munthu watenga when doing a certain activity. So these are 3 of the 7 fundamental quantities. So what are the others? We have a fundamental quantity called current or electric current in full current. Another quantity is called amount of substance. And then we have another quantity called luminous intensity. Okay, so we are going to be discussing these quantities. Here I've written 6. I'm going to list the 7th as we go along. For now, let me prepare a table for you. So for now, you may not see something on the screen. I'm trying to prepare a table which you cannot see for now, but that table is going to help us to understand these quantities, especially the derived quantities. So pardon me as we go blank for these few seconds. It will take long. Right, now we are back with the discussion on these quantities. Okay, so let's, before we forget, let's finish the last one left. Temperature. Temperature is also a fundamental quantity. What that means is the other quantities that have not been mentioned here, if you know another quantity, that quantity is a derived quantity. That means that quantity is a combination of 2 or more of those fundamental quantities. So what are the derived quantities? Without much ado, we'll start discussing the most known derived quantities, starting from a quantity called volume. Volume is not a fundamental quantity because inside the volume there are 3 lengths. You can say it is length times width times height, but all those things, length ndi utali wa utali, width ndi utali, so height so ndi utali, so zikamba bechinthu cha length utali kaukhakoka. So izozo zili ma dimension are length only. So volume is simply dimension ya length kuzibwereza yokha kawiri, so we take it as capital L to the power 3, meaning kuti volume yo imabwereza yokha dimension ya length. Tikamati dimension imakhala kamba kuti chinthu chimene chofe tikamalingalira mutu mwathu chimakhala chani. Ngati apa tikamati length kaya unena mulifupi kaya mulitali, komano dimension yake timayitchula kuti L. So it doesn't matter kuti kaya mulifupi kaya mulitali, chimodzimodzi masi kaya masi yo ndi achani, komano timakhala ndi ganizo la kulemera ndi ganizo limene timalemba kuti M, dimension M. Chimodzimodzi time, dimension capital P. Ndi tikamagamba ma dimension makhala kuti timakhala tikuganiza chani tikamagamba za chinthu chimene chocho as we go along. For now, zofunikira kwambiri ndi zimene ndazilemba abazi. The dimension of temperature, okay, which can be written as K. Fine. For now, I'm not going to demonstrate with the volume. See, the volume is a combination of 3 lengths, length times length times length. Although you can give different names to the lengths, but it is still length. Okay. Another derived quantity is called density. I believe density is not a new thing to you, so it will be very important for us to be able to define these terms. So let's go to the rigorous definition of each of these. When we talk of volume, we're talking about the amount of space. So amount of space is a quantity. We can measure it. The amount of space inside something or inside an object. Kapena, the amount of space occupied by a solid object. Occupied by an object. Mwachitsanzo, space imene mwala yatenga, space imene ndi volume ya mwalawo. Space imene ili nkati mwa botolo, space imene ndi volume ya botolo, the amount of space it can be measured. Whilst density is a term that relates to how many particles of matter there are in a particular space. I believe with the introduction to the kinetic theory of matter, you learned that matter is made up of particles, and those particles are arranged in different ways. Okay, so there are some substances that have more particles within the same space. Pamene ena within the same space yofana ndi yomweyo amakhala ndi fewer particles. Ndiye kuti no kapakidwe kama particles ukakusiyana, the closeness of the particles. Let's describe some matter here where the particles are very far apart. Okay, so within the same unit volume, we can take unit volume. Unit volume is volume ya 1. Kaya 1 cubic meter, 1 cubic centimeter, kaya 1 chan, as long as it is 1. So within that volume, per substance imakhala particle wangati within the same volume. So the amount of particles or the number of particles that is available per unit space for a certain substance is called the density of that substance. Volume is denoted by the letter V, and the density is denoted by the letter rho, which looks like a V. So rho is taken as a quotient of mass divided by volume mathematically. So looking at that mathematical definition, we can therefore define density as the mass per unit volume. Mass per unit volume. So we see that density is also a derived quantity because it is combining a number of things, as we can see here. Alright, another derived quantity is called area. Let us talk about area. Why is area a derived quantity? Area is found by multiplying two dimensions of length. So area is length times length, or length to the power 2. Every formula area makala dimension awili are length. For example, the area of a circle, we say area is equal to pi multiplied by radius squared. So radius squared means radius is belezeoka kawiri, radius times radius. So you see there are two dimensions of radius there. So kaikala area of a rectangle we call length times length, bakala length times width, which are two dimensions of length in that case. So area is also a derived quantity because it is a combination of or a repetition of a base quantity called length. Proceeding, we are going to look at another derived quantity called pressure. Pressure is the amount of force that is exerted by an object per unit area. Force per unit area is called pressure. We are going to dwell much on some of these definitions when we reach the topics that discuss those definitions. Okay, so based on that definition, we can say that pressure is equal to force over area. So we see that there is a combination of a derived quantity called force and area, which is also a derived quantity. Why are we calling force a derived quantity? Now we are going to look at that quantity as well. A quantity called force. Force is in fundamental quantities. Basically, define force the amount of, or rather the amount of a pull or a push, or not a pull or a push on an object. That is called a force. Yeah. Force must define most of it was very difficult, but with the blessing that came on earth called Isaac Newton, now it is easy for us to understand what a force is. Isaac Newton was very much interested in forces and mechanics, as well as calculus. So he was wondering what was causing the falling of an apple in a particular field or in an orchard. After discussing with himself, of course, he found out that there must be a force downward the earth which pulls everything down. Even if something goes up, that force will pull that thing down. So he conducted a number of calculations involving that force called gravity, and that led to the discovery of the definition of a force. Isaac Newton made a law which came to be called the Newton's second law of motion, which says that force is equal to mass times acceleration. So we see that force is a derived quantity because you can combine a single quantity kama basic quantity yochedwa mass ndi derived quantity yochedwa acceleration. Ndikuti force ndi combination ya ma quantity angapo oposa awiri chifukwa mu acceleration muliso ma quantity ena. Okay, what is acceleration itself? Acceleration as a derived quantity again nayo also is defined mathematically as A equal to V minus U divided by time. V minus U over T. So what is V minus U? V minus U is change in velocity, the speed of the motion of something. That is called V. So final velocity is taken as V. The velocity of is taken as U. So taking V minus U means how the velocity has changed. Now, when we divide something by time, it means we are finding the rate of that thing. In physics, whenever you hear the word rate of, just know that we are saying time. So if your name is Joseph, the rate of Joseph is going to be Joseph over time, in short. Okay, so acceleration is change in velocity divided by time. Now you see, change in velocity is a quantity. Of course, the velocity on its own now also the derived quantity, but time is a base quantity. So acceleration is a combination of time and the other derived quantities as well. So that makes it a derived quantity. So we are closing in. Therefore, we have to look at velocity itself. Then what is velocity? Velocity is defined as rate of change of displacement. So you can see now that things are getting more interesting because later we need to define displacement itself. Rate of change of displacement. That means velocity mathematically should be equal to the change in displacement, which is simply denoted as AC, displacement divided by time. Displacement is also a quantity. Dimension and length. So velocity is like a length over time. Dimension of length divided by dimension of time. That makes it a derived quantity. Then what is displacement itself? Displacement means distance in a particular direction. So because displacement means distance, then you want to be in the category of derived quantities because displacement is just a distance. Okay. Some of these quantities are going to be derived fully in a later class when we start talking about mechanical quantities, because it is very important that we discuss what these quantities are. But this lesson only aimed at introducing the concept of a quantity. If there is any question, please do ask. The questions are going to be attended to. Thank you very much.